So, have you ever really stopped to think about it? Space is full of giant, chaotic events, stars colliding, galaxies merging. But it's completely, totally silent. Why is that? Well, let's get into it, because the answer shows just how different real space is from what we see in the movies. Okay, first up, a little pop quiz for you. I'm about to show you one of the most iconic scenes in movie history, but scientifically, it gets something huge fundamentally wrong. See if you can spot it. And there it is, the destruction of the Death Star. You've got this massive, fiery explosion and that deep, satisfying kaboom. It's an amazing moment on screen for sure, but that sound, that's exactly where the fiction begins. Which brings us to what I like to call Hollywood's loud lie. We're going to break down exactly why those incredible space battles you see on screen would actually be silent, eerie spectacles in real life. I mean, think about it. From Star Wars to Star Trek, space is a really noisy place in the movies, right? You've got lasers going pew-pew and ships roaring past the camera, explosions are loud, they're dramatic, and they make for great action. It makes total sense why they do it, but it's just not how it works. The truth is, space is quiet. Like, really, really quiet. And the whole reason comes down to one simple fact. Space is a vacuum. It's missing the one thing sound absolutely has to have to exist, a medium. Or, to put it another way, there's just not enough stuff out there for sound to travel through.
Okay, so to really get why a vacuum is silent, we need to do a quick refresh on how sound even works here on Earth. And you know what? It's all about vibrations.
At its most basic, sound is just a vibration, a pressure wave. But for that vibration to get from one place to another, it needs something to travel through. It needs a medium. That could be air or water or even a solid object. It absolutely cannot travel through nothing. And this slide breaks it down perfectly. Think of it like a row of dominoes. When I speak, my vocal cords vibrate, and that vibration pushes the air molecules right in front of my mouth. Then those molecules bump into the molecules next to them, which bump into their neighbors, creating this chain reaction, a wave that travels all the way to your eardrum. If you don't have any molecules, you don't have any dominoes to knock over. No domino effect, no sound. Simple as that. So, this leads to the real heart of the matter, the emptiness of space. We all use the word vacuum, but what does that really mean? Just how empty are we talking about here? While scientifically, a vacuum isn't completely 100% empty. It just means it's a space where particles are way, way more spread out than they are here on Earth. So there are some particles out there, but they're incredibly few and far between. And this table, wow. This really puts it into perspective. Just look at these numbers. Here on Earth, in a tiny little box of air the size of a sugar cube, there are about 10 times quintillion particles. But in the deep vacuum of space, that exact same sized box has maybe 10 million. That is a mind-bogglingly huge drop in density. Now that huge difference in density leads to this really cool concept called the mean free path. And it's pretty much what it sounds like. It's the average distance a single particle can travel completely freely before it finally bumps into another particle. Here on Earth, that distance is a tiny, tiny fraction of a centimeter. But in space, a single particle can travel, on average, about 100 kilometers before it hits anything else. That's insane. That's like driving from one city to the next and not passing a single other car. All right, so now we have the two big pieces of the puzzle, right? We know how sound works, and we know just how incredibly empty space is. So let's connect those dots. It all comes down to this. On Earth, the air molecules, our dominoes, are packed super close together, ready to pass along a vibration. But in space, the dominoes are so far apart that if you knock one over, it has nothing to hit. The chain reaction is broken before it even starts. You know, this brings up a really good practical question. If you can't just shout to your buddy in space, how do astronauts actually talk to each other? Well, they use radio waves, which are a form of light, to send their voices back and forth through their helmet communicators. So let's circle all the way back to where we started, that big Hollywood explosion. Now that we know the science, what would a real cosmic explosion actually be like? Well, it would still be a heck of a show, just a totally silent one. And let's be super clear, explosions absolutely happen in space. I'm talking about things like supernovas or asteroid collisions. They are real and they are unbelievably powerful. They throw out massive amounts of energy, light, and debris. The explosion itself isn't the fictional part.
So a real space explosion would be incredible to see. You'd get a brilliant, blinding flash of light, and you'd see all this material flying outwards. But you wouldn't get any fire because fire needs oxygen to burn, and there's none of that in a vacuum. And most importantly, no kaboom, no shockwave, nothing. Just a completely, utterly silent and beautiful display of cosmic power.
And this really is the bottom line. If two astronauts were floating right next to each other and they took their helmets off, which they shouldn't do, they could shout at the top of their lungs and they wouldn't hear a single sound. The vibrations would leave their mouths and just die in the void.
So, space is silent. But that's just scratching the surface, isn't it? It kind of makes you wonder, what other laws of physics do our favorite sci-fi movies bend to tell a good story? Something to think about the next time you see a spaceship banking like a fighter jet in zero gravity. Turns out, science is often a lot quieter, but it's no less spectacular than fiction.